Alright, welcome back YouTube. I have my dueling Tesla coil set up right here. I just wanted to clear up any misconceptions as to input voltages, output voltages, input currents, output currents, stuff like that. And unfortunately, like I said in previous videos, whenever I try to directly measure these with a voltmeter, as far as voltage and amperage, I get nothing. The circuit falls out of resonance, and then I can't measure it. However, there is another way I can use to measure current. Well, not really measure, but at least demonstrate the lack of drawing current. So just so you guys can see, I got this one fired up, and then I got this one also fired up, getting similar output from the CFL. This is the the 27 water. Yep, this is the 27 water. Okay, you can see that I'm definitely getting the same output from the two coils. And then let me go into greater details what I'm powering these coils. This is going to start cleaning up many misconceptions. So this coil over here is being driven by my laptop charger. Okay, I'm not sure if we can get that in any focus, but this is 19 volts at 3.94 amps. Okay, I'm driving this coil off of a different transformer. Let me unplug him. I'm gonna reach under there. Gonna grab him, put him on the desk. Alright, you can see I'm not kicking no more. I'm not lighting the LEDs. Okay, oh wait. It's actually picking up. Oh, wait a minute, hold on. It's actually picking up a little signal from this one over here. But as you can see, it's not powered on anymore. It's not lighting the CFL. Okay, so we know this one's not being directly powered, even though it is picking up some power from that coil. Oh, I see it lighting up over there. Not here. So, here we go. Let me focus in there. And what do you guys see? Output. 15 volts DC at 1 amp. Okay. Not terrible. So this guy, going back to this guy, we have 19 volts at 3.95 amps. Okay. Now this one is slightly brighter. This one has slightly more output. However, it is not due to the increase in amperage. It's strictly due to that extra 4 volts. These guys are not drawing more than an amp, and I dare say they're drawing less than an amp. So as far as everyone questioning whether or not you know it's more or less efficient to drive these CFLs off a device like this, I would tend to argue it's more efficient to drive a CFL off a system like this, because the output voltage is at such a high frequency that it more efficiently excites the gas within the bulb. And the same thing with the LEDs. This tree, I have a tree plugged in now, but I already had another video demonstrating how well these things light LEDs, and a lot of them at that. So there it is. So I have two similar voltage sources with two totally different current outputs, and I'm getting the same visual output as far as brightness of the CFLs are concerned. So there it is again, 19 volts at 395 amps, and then this guy 15 volts at 1 amp. Let me plug him back in. I'm going to plug this guy back in into the wall, right under there. Okay. Okay, he's kicking now. Let's see. And we have our light. Let's go over to the other coil. Look at that. Let me zoom out a bit so you can get the whole picture here. There's that guy. And then there's that guy. Now it appears that the more bulbs that I add does not increase the load to the transformer. Eventually what happens is the circuit falls out of resonance, and eventually it just won't light up any more bulbs and it'll just stop. But I don't think it actually, the more bulbs I put here will load the transformer, or at least the battery. It doesn't appear to be that way, but then again I don't have a way to measure the current directly. But even if it did, it's still less than an amp, regardless of how many bulbs that I connect to the circuit. So here we go. We have 1 amp, 4 amps. 1 amp and 4 amps again. No difference. Or if there is a difference, it's very little, and it's only due to the fact that this is 15 volts and this guy is 19 volts. I'm actually working on getting a DC power supply soon that'll crank up to 40 volts, and then I plan on limiting that current to 500 milliamps, and I expect to see amazing results, the best results I've ever seen. As soon as I do get that DC power supply, I'll post that video up on YouTube too. But in the meantime, I'm just going to keep doing what I can do with the resources that I have now to demonstrate the key properties of this circuit. Don't forget to like and subscribe, and I'll come back to you with more videos.